Hi, this is the video presentation of Project 2, and I'm Kolo Ing. I will be the video presenter throughout this video. So, our group member consists of Lim Yuhan, me, and also Wu Cheng Suan. Let's start our Project 2 by seeing the topic first. So, the topic we've chosen are the heart attack and its contributing factors, and our goals of this project is to perform the statistical analysis on secondary data, and also we want to investigate the relationship between the selected variables on the secondary data. So for the dataset part, we will find our dataset in the Kangar website. So the dataset are heart attack risk prediction dataset, and the population of it will be heart attack disease patients around the globe, and we have taken the 8,763 patients as our sample to investigate. So the variable taken will be age, gender, heart rate, BMI, cholesterol, smoker, and also the heart attack risk. So for the objectives, we have 4 objectives to investigate, which we want to investigate if there is a difference between the heart rate of male and the heart rate of female patients. For the second one, we want to investigate the relationship between the age and heart rate of the patient. For number 3, we want to provide insight if cholesterol is a predictor of BMI. For the fourth objective, we want to investigate the interdependence between the smoker and also the risk of the heart attack of the patient. So, to carry out this investigation, we will do different tests on it to find out what is their relationship. So for the first one, we want to find out the difference between the mean heart rate of the female and mean heart rate of the male. We have written the hypothesis statement here, where male 1 is the mean heart rate of the female and male 2 is the mean heart rate of the male. We have carried out the hypothesis test with 2 samples by knowing the 2 mean on to investigate their relationship. So we have getting the t-value equals to 1.0197 from this test, and the p-value of it is 0.3079, which this value has more than the 0.05 significant level, which means that we have failed to reject the null hypothesis. We have failed to reject the H0 here. The conclusion we can make is there's insufficient evidence to support the claim that the mean heart rate of the female is different with the mean heart rate of the male. So in other words, from the dataset we get, we found out that the mean heart rate of female will be same as the mean heart rate of the male. So maybe the gender are not the main indicator of the heart rate. So for the second one, we want to investigate the relationship between the age and the heart rate. So is the heart rate dependent on the age? So first, we have made a scatter plot on it to visualize the data. And from the data here, we can see that the data points spread without any clear pattern and trends. So this means that they will have the extremely weak linear relationship. We doesn't see any relationship exist from this scatter plot. So we have carried out a correlation test to test whether the age and heart rate they has linear relationship or not. So this is the hypothesis statement we made. The H0 is whether the age and heart rate have no linear correlation or they have the linear correlation. So we get the t-value is negative 0.359831, which means that they have a weak negative linear relationship. So for the p-value is 0.719, which means it has more than the significant level 0.05. So we fail to reject the null hypothesis. For the conclusion, we have not enough evidence to support the claim that there is a linear relationship between the age and the heart rate of the patients at a significant level of 0.05. So maybe there are other influence besides age may play a more significant role in determining the heart rate. The next part, we want to investigate the relationship between the BMI and cholesterol levels. So we have also made a scatter plot for it to visualize the data we have. So from this scatter plot, we can see that it has a wide dispersion of the data points. It didn't have any patterns in it. So which means that it has an extremely weak linear relationship between the BMI and also cholesterol levels. So we have carried out the regression test to test whether the cholesterol has linear relationship with BMI or not. So this is the hypothesis statement we made. After the regression test, we found out that this is its equation with the positive slope, and the R square is 0.0003, which means that it's very close to the zero. This indicates that they have a weak linear relationship, and the t-value we get is 1.619. The p-value of it is 0.1055, which more than the significant level again. Thus, we fail to reject the null hypothesis again. For the conclusion we can make, there's insufficient evidence to support the claim that the cholesterol has linear relationship with the BMI. So cholesterol is more related to the diet and the lifestyle, so it may not significantly impact the BMI of the patient. So for the last objective, we want to investigate the independence between the smoker and risk of the heart attack. This is the hypothesis statement we get. Whether both variables are independent or dependent, and the variables will be a smoker and a heart attack. We have carried out the chi-square test and contingency analysis, and the x-square value we get is 0.144. The p-value of it is 0.7045, which more than the 0.05 significant level again. Hence, we fail to reject the null hypothesis again by doing the chi-square test. For the conclusion we can make, there is insufficient evidence to support the claim that the smoker and the heart attack risk are dependent at 95% of the confidence level. So, for the conclusion, all the null hypotheses are failed to reject, and at the confidence level of 95%, there are not enough evidence to support all the claims at here. So the dataset we get will give us the conclusion that is different with the real-life situation because of so many reasons become the factor of the heart attack risk, but not only the variables we investigate. That's all from us. Thank you.